Okay, the last part of the review deals with half-life problems, and so there's two formulas we need to know. First, how to calculate the number of half-lives. So we're going to take the elapsed time divided by the known half-life. That'll give us the number of half-lives. And then the other one deals with an amount. So I'm going to take my initial amount divided by 2 to the nth power, where n is the number of half-lives, and this will tell us the final amount. And so between those two equations, we can solve these problems. And so in looking at this one, okay, so we know the elapsed time is 57.2 days. We know the known half-life is 14.3 days. If I divide those, that tells me 4 half-lives. Well, the initial quantity was 4 milligrams. So 4 milligrams divided by 2 to the 4th power, so 2 caret 4. And so 4 divided by 2 caret 4 will give me 0.25 milligrams. For number 38, same type of deal. Elapsed time, 415.2 days. The known half-life is 138.4 days. Divide those out, that's 3 half-lives, okay? Well, it says I started out with 2 milligrams, so 2 milligrams divided by 2 caret 3, so 2 to the 3rd, gives me, once again, another 0.25 milligrams. So same answer, but different problem. That's okay. Okay, next. Radioactive material. And so it tells me how many nuclei. It says the half-life is 2 hours. How many are left after 8? Elapsed time, 8 hours. Known half-life, 2 hours. Divide that out. That should give us 4 half-lives. I start out with 2,000 radioactive nuclei. I divide that by 2 to the 4th. There should be 125 nuclei remaining. Number 40, same type of deal. Okay, so I know the elapsed time is 7.32 days. Known half-life is 3.66 days. Divide that, that gives me 2 half-lives. This time I do not know the initial amount. I know that 2 caret 2 is equal to the final amount, which is 0.500 grams. I have to cross multiply, so 0.05 times 2 to the caret 2, or 2 squared, will give me 0.2 milligrams. Or excuse me, just grams, not milligrams, just grams. This was in grams. Okay, next one. It says a radioactive material is observed to have 3,200 unstable nuclei. If 8 hours later there's 200 left, how many, what's its half-life in hours? So we need to figure out how long it takes to chop 32 in half to get down to 200. Well, if I start with 3,200, well, half of that is 1,600. Half of 1,600 is 800. Half of 800 is 400. Half of 400 is 200. So that was 1, 2, 3, 4 half-lives that have elapsed. Okay? And so I know that the elapsed time is 8 hours. And I know that it's 4 half-lives. I need to solve for x. So essentially what happens, these two things switch places. 8 divided by 4, 2 hours is the half-life. And then the last one, this one deals with a fraction, okay? And so, or it's not a fraction, I guess it's looking at, once again, I guess half-life. So what is it? 16 going down to 1. So if I start at 16, it goes to 8. 8 goes to 4. 4 goes to 2. 2 goes to 1, okay? And so as I do this, that is 1 half-life, 2 half-lives, 3 half-lives, 4 half-lives. So 4 half-lives have elapsed. Okay, I know that the time is 12 hours. I don't know the known half-life. I know this is 4 half-lives. These two switch. 12 divided by 4, 3 hours. Oh no, I'm sorry, minutes. I wasn't paying attention. It does say minutes. 12 minutes, or 3 minutes.